Welcome to Lab 2, the motion of a falling object. In this lab, we are to observe the motion of an object dropped from rest that fell somewhat slowly straight down. Using Newton's second law, we observed the effect of gravity and the drag forces. We are to model the effect knowing that the drag force is in the direction opposite of the direction of the object's motion. In this lab, I used a fake lemon to drop. It's hollow on the inside, so it's very light and weighs less than a small rock would. I took a video of myself dropping the lemon and uploaded it to Tracker. In Tracker, I first set the axis with the origin at the center of the lemon. I then added a calibration stick and typed in the diameter of the lemon, which was 9 centimeters. I changed it to meters, so I typed it in as 0.09. Just like in the first lab, we tracked the position of the lemon as it went down. We changed the axis so that it would show the y-axis. I set my origins so that the lemon would be moving in the negative y direction. I chose to go from frames 200 to 220 because it was the time that the lemon left my hand to the time that the lemon hit the floor. This way, the initial velocity and final velocity were both 0. The time that these frames occurred was from time t equals 0 to time t equals 0.792 seconds. The initial velocity was 0, and the initial position was also 0. I started the position at the origin and moved down the negative y direction. The final position is shown here on the screen. We then went to the Python model to create a model of the motion. In the Python model, we edited it so that it would fit my model. The mass of the lemon was 0.015. The initial position and velocity were both a 0 vector, and the time started at 0. In the first model, B was set equal to 0, and the net force was only equal to the force of the weight, which is the force of the earth pulling down on the lemon. I uploaded that data into a Google Drive. It is as shown in the experiment on the left. The experiment position that I modeled is the blue line, and the model from the Python is the red line. The red line is showing that the lemon should have traveled farther than it did in the time that it traveled. This is explained when we add the drag to the model. Going back to Python, we can add the drag force. The drag force is equal to the ball times the ball's velocity times negative b. We also had to make sure that we set the magnitude of the drag force proportional to the square of the object's speed. This is why the ball's velocity is in there twice. We changed the net force so that it would be the weight plus the force of the drag. We put it into the Google Doc and created a new graph. Here you can see that the model position with the drag is much more accurate compared to the experiment positions. It shows that the lemon had larger drag force than some other object. In this model, we can see that the experiment and the model position, including the drag, start at the same point and end towards the same point. There is just some discrepancy in the middle. This could be due to user error of not knowing exactly where the lemon was in the tracker model, as it was blurred on the way down. It is also much more realistic that the fake lemon would fall less than 2 meters during the time period. If it fell the complete 3 meters, it is a little bit unrealistic. The terminal velocity of a falling object is the velocity of the object when the sum of the drag force equals the downward force of gravity. The net force is still 0, which means there is no acceleration. In our example, this happens towards the bottom here. If the object were initially thrown downward, there would be an acceleration component and the terminal velocity would not exist. Overall, we can see that Newton's second law still applies when the object is in motion. The net force is equal to the force of the drag plus the downward force of the gravity.